Hi, my name's Oriana Bretschker, and I'm the CEO and founder at Aquacycl, and welcome to Wastewater Wednesday. So today we're going to talk a bit about 3 ways to flow segregation to help your business save money and optimize your process relative to wastewater management. All right, so when we're talking about flow segregation, it can sound really overwhelming. You don't want to add a bunch of infrastructure, you don't want to have a bunch of extra plumbing, you don't want to have to maintain a whole bunch of extra lines. Well, the good news is you can actually probably do this quite simply if you're not doing it already. So let's talk about a couple of examples, whether we're talking about a periodic timing issue where you want to capture something that's consistently made daily and treat it, or if it's a bad batch of something something went wrong in production, and how do you capture that? So there's 3 primary ways that you can deal with flow segregation in your production process. One is highlighting different areas in your process that actually generate wastewater, understanding what kind of wastewater is generated out of each process, and then capturing it as it's generated. So for example, if you have a batch room where you're producing syrup or concentrates, that's typically going to run for a fixed cycle. And you know that on the first rinse of the CIP, or if you have a bad batch, right, you're going to have some concentrated wastewaters that are coming out of those 2 processes that you can capture, collect, and manage separately so it doesn't send to sewer and create additional surcharges. The other way to segregate is based on timing. So kind of again back to those batch cycles. If you have a fixed batch process that you know happens predictably on a daily basis, you can simply set up a diversion process based on the timing of which you're producing that batch. Segregate it, manage it separately, reduce your costs, optimize your management process. Easiest way is, right now, almost all of your effluent is likely going to fall into one singular floor sump. And that sump is going to divert all of your flows either out to the city or to a different collection system that's adjacent to your production facility. Now, you can actually put in metering and valving. That's based on logic. That will actually measure the organic pollution of whatever you're sending down to that sump at any given period of time. Now, you can set your thresholds so that if the organic content is higher than what the city sewer really wants to take, or what your treatment plant is designed specifically to handle, you can divert that wastewater to a separate holding tank. And all of that can be done in your existing infrastructure with some simple metering with logic controls. And then finally, if you do have on-site wastewater treatment, you may be actually generating additional waste streams that you have to manage independently. These could be waste-activated sludge from an aerobic process. It could be digestate from an anaerobic digester. These are going to be waste streams that are typically difficult to handle in a conventional wastewater treatment plant. They're going to the collection system. You may have to haul them off-site. So if you have a treatment plant on-site and you're creating these extra waste streams that have to be managed independently, easiest thing to do, add another tank. All of that digestate or that waste-activated sludge that you're generating, if you're hauling it, you already have the tank there. So instead of having a truck come in and empty it for you, simply treat it on site and recycle that water back into your existing process. It can enable a better level of reuse, more sustainability, less chemical consumption, and overall, less sludge into the environment. There are technologies that you can now implement, like Aquacycl, to handle some of these waste byproducts, in addition to those bad batches and other segregated streams. You can treat it directly, without dilution, and without hauling. Find out more at aquacycl.com.